So resuming to this table. So okay, so you will notice here that this is the sum for this one. So starting from here and here. So that is for your loss per section. And we have starting from here going down here until dito. So ito yung sum niya. Then we have also nito, which is yung sum niya ay ito. Now last part we have ano yan, so that will be, so we have the value of 7 point, so let's change the code. So this will be 7.813. Okay, so this is the sum of nito. So ito yung sum. So ito yung sum nito for this one. Now for the cumulative loss, okay, so for the cumulative loss, so we'll be putting here the total loss dito sa taas. Okay. So it will be the sum of 32.34 then from this one, and this one. Okay, so that will be the sum of 32.34 plus, so that will be plus 116.64 plus 1.233 plus 7.813. So we have the value of the value of 158.026. So we have the value of 158.026. So this is the sum of the whole system. Ito yan. Now so we have your cumulative loss. So starting from here, okay, so the sum naman ng nasa baba, so you have the value of, so that will be the sum of so that will be the sum of 116.64 plus okay, so this will be the sum of 116.64 plus 1.233 plus 7.813. Then we have the value of 125. So it will be starting from here. Okay, we have the value of 125 here. 125.686. Then pababa na naman, we have so we have So this will be 1.233 plus 7.813. So we have 15.626626. Okay. Then lastly we have your pinakababa niyan, summary of that one. So that will be 7.813. Now if we're going to add this one, so the summation of this one is also in ito ng value niya. So you have the total loss of 158.026. So that will be the total loss ng section na ito. Okay. So what I have here now is we have the sizing summary sheet. Okay, so since nakuha na natin yung isang part na yan, so we have the summary ng system na yan. So we have your duck run. So duck run natin, so that will be from our previous worksheet. So that will be A-D1. Okay. So this will be duck run, that will be A. So this will be A-D1. So we have your so you will be putting the diagram, and you will indicate the flow starting from here. So just only by putting the the arrow saan papunta yung flow, so which we can be able to distinguish. Okay. So we have now flowing going here. Now for the total loss, okay, so the same also what we have on the value here. So we have 158.026. So we have your value here, 158.06. So that is for the diagram now going there. So next we'll be computing na naman. We're going to compute next is the duck run starting from here and going here. So this will be C1, and I will mark this one as C2. We can name this one as C3. Okay, so here we're going to erase this one all, and we'll start computing naman ng duck run from starting so C3. Okay, so resuming from the last time that we had topic, okay, so we are now considering the point from here, so that will be the root of A to Z3. So we're going to put here duck run A to Z3. So that is the duck run here. So we have here duck run A to Z3. So we'll be starting again yung section. So we have your section. So katulad yung kanina last time. So we have here running here, going here. Okay, then another here going here dito sa branches na we can usually, so since ito nakuha na natin ito sa previous values natin. So we can use those also the same value since we already computed this part. Okay, so we can import yung values nung our previous calculation. So we have your a-1 a to b, so that will be the duck. Okay, so again it is the symbol from a to b at this portion, and then we have your c1 for your duck, c1 to c. So we have your previous value from c1 to c. Now since we have also your p-loss, this is from p-loss from c to d, so we have your p-loss from c to d. So this is also duck, okay, from main duck. Then I think this one, p-loss c to d. Okay, so I think we have to remove this one. So since it is c to d, so it is considering from starting from here going here, so which is not part of the run of a to z, duck run of a to c3. Okay, so we remove that one. So we're not considering only on this part at c1 to c. Okay, so c1 to c only, the duck. Okay. Now we're going to the branches going here from your main duck going to your branches. So we have your losses also. Okay, so we can use this again yung we have, so this is an illustration of your from your T rectangular main branch. Okay, so we have here your table. So we have the ratio of the Boolean flow rate from here branches to the main duct. Now your main branch, so from our drawing, so we can check that our main branch, that will be 600 CFM. Okay, so this is then the branches, this sa ilalim we have 600 CFM, so this will be 600 CFM. Okay, then our branches, that is 40 CFM. So regarding what type of unit that you use, bas as long na magka-cancel out sila yung value. So we have the value of this will be 0.067. Okay, round off natin. So you will notice again value. So if you're going to check the chart, so wala siya dito. Okay, so again we'll be using yung pinakabababa kahit na natin in order to have a value which is will also provide us a factor on safety ng design natin. Okay, then on the other side of our table, so that will be the ratio ng velocity from here, okay, then velocity from here. So we can rewrite your velocity, so that will be the velocity ng branches, so velocity c1 divided by the velocity from your main duct, velocity c2. Okay, then if you can see, so that will be velocity c1 and velocity to c2, c2 or pwede rin c3, so it is the same, c2 or c3 at this point. Ito, so the velocity from here and here are also the same. So our value for the c1, okay, so that is the duct. Okay, so we'll check the table ng previous natin, which is yung in-import din natin na value. So we have 3.78 yung Z1. So that is the ratio. correction lang dito. So we nagkamali lang sa equation. We correct it to C2 to C1. So that is the ratio of your branches over the main duct. Okay. So we have now the ratio. So since yung volume flow rate nito at saka nito are the same. So yung volume flow rate natin ng Q D2 is equal to QC3. And also yung area, yung cross-sectional area ng duct ng AD2 is equal to AC3. So they have the same area, same volume flow rate, then we can also get the same velocity. Yung velocity ng BD2 will also equal to the velocity of BC3. So the value of BD2, so that will be the 0.94 meter per second. Okay. .94 meter per second. You have the value now. So also you can compute naman ito by means ng ating volume flow rate. So kung ano kayo, diskumpiyado kayo, if you're not confident, so you can also compute it by means of your continuity equation, area times the velocity. So you will arrive at the same amount that also I have here, 0.94 meter per second. Okay, so we have the value of C1 to C. So this is your duct, C1 to C. Then from our table, we have the value of the velocity is 3.78 meter per second. So substitute that one in our. So we have the value of 3.78 so meter per second. And we have the value of 0.24, or let's say 20, this is 8, or we can say that is 0.25 to around near it. Okay, so from here we have only the value of 0.2 to 0.4. Okay. So we can use also, since this one is in between ng value, we can also interpolate yung value natin from this one to this one. So if we're going to do an interpolation, usually pwede mo naman gamitin yung value 0.2, but for the purpose of kasi usually in engineering we base only on the calculation that we have, then that is usually class in actual. So pag nagko-compute kayo, nobody can tell if your calculation is correct. It is by means of by means of experience. You can justify, or let's say you can say that their calculation is correct or wrong. So that is by means of your own judgment and in your own experience usually. So what we have here now, okay, so we have 0.2, that will be minus of 0.25, so divided by 0.2 minus 0.4, that will be equal to 0.91 minus the value of x, then that will be 0.91 minus 0.81, or we can rewrite this equation as, so this part that will be 0.25, so minus ng value ng dito, so let's try to erase this one, so this is multiplied by 0.1, then that will be 0.91 minus x, and we have the value of your x in between, or the value of your coefficient of then we have now the value of positive 0.885. so notice, so this is ascending from here going here, okay, so we are in between 0.885, so our calculation is, we can justify our calculation is correct. So again, rewriting our equation for P loss for the branches, we have your P loss, so that will be your P loss, okay, divided by the velocity, that will be velocity C2, so that will be multiplied by your density divided by 2, which is equal to 0.885. then we have your P loss for that branches, that will be 0.885, then multiplied by velocity C2, where velocity C2 is 0.94, so that will be meter per second, then multiplied by the density. So the density, what is our density? Okay, referring to the density of your air, that will be 1.21, so ito yan, so kilogram per cubic meter. Then okay, then we're going to divide this one, the velocity divided and density divided by 2. Finally, we have the value for the P loss on that section. Okay, so we have now the pressure loss of 0.5 Pascal. Okay. So checking the units again from time to time. Okay, so okay, parang may kulang tayo. Okay, checking. We forgot to put the square on this part, so that will be meter squared and second squared. Okay. So we have now the value of 0.5, so to round up 0.5 Pascal. Okay, so that's why pareho rin sila, but this pag ito ay naging malaki yung velocity mo, so it has a big difference. So that's why every time I always check yung units, napaka-importante just to make sure na tama ba. So usually we forgot to square this one, so magiging unit niya, which is yung aqua, magiging final unit niya will be kilogram per second. Okay, kilogram, usually cancel mo meter, kilogram square meter second, so we cannot achieve the kilogram meter per second squared. So that's why napaka-importante pa rin you check your units all the time. So we'll be putting here, so this is branch take off, okay. Then we have the volume flow rate for this part, so we have the value of 18.87 for the liters per second. Okay, so the same also we have yung our previous calculation, so we have here, so that will be also 229.22, just only importing yung value na rin since we calculated that one in our previous calculation. Okay, so we have 229.22. Then also we can refer on this one, so since we have also the same value no kanina, so we have your preparing yung value ng Reynolds number natin, you can refer also to your previous calculation. so that will be 8,332. Okay, just import the value. So this will be 8,332, and this is also a turbulent flow. Okay. Size, so this is branch takeoff, pillows only. Viscosity of your air is the same also, 18.154 times 10 to the power of -6. Then the velocity will be 0.94. Okay, double check. I want to double check that one. So 0.94 meter per second. Then our duct, okay, we don't have the duct length, so the change in elevation is also don't have the one natin. Disregard. Air density, that will be 1.21 kilogram per cubic meter. Specific weight also the same, so this is 111.87. Then your friction factor, what we have get that it will be 0.8. 0. I can input that one, 0.885 friction factor or coefficient. Okay, then we have the loss of 0.5 Pascal. Okay, 0.5 Pascal. Okay, so next we're going to compute now from here. So we have your duct run from Z2 to Z3. Okay, so we're going to put here C2 to C3, and also you can also put, so nadagdagan nga usually, or we can put also Z to Z3, so they are the same. So this is also can be the same, which is C to Z3. Okay, so we're going to put this one. This is a duct. Okay, they are duct. Then we have your volume flow rate, which is also 18.87, the same nung sa taas. And this is 229.22. Then you have your Reynolds number, which is 8,332, and this is a turbulent flow. Then the size of the duct will be how much? This one. So referring yung ginamit natin last time, so we have the duct which is 200 by 100. Okay. So the size of duct will be 200 by 100. 200 by 100. Then we have your viscosity of your air, 154 times 10 to the power of -6, and you have the velocity of 0.94. Okay. Then the duct length, so we can also refer and also import the value of yung previous data natin, which is 1.1 meter. Okay, so considering they are equal length, so usually just kinaka-copy paste lang usually in CAD5, and we can put that one. So this will be the duct length, that will be 1.1 meter per second. Okay, change in elevation, so we have 0 since wala tayong elevation. Then the D equivalent, we can use also that one. Okay, referring to that duct 1, 1.1, so your D equivalent is 0.272. 0.272, 0.272, and we have the density again the same, 1.21. Then we have also your specific weight is also the same, 87, and the friction factor. So again, we can use yung value na yun. Since since yung same characteristic din sila, same temperature, same viscosity, and same length also we use, so we can use also the friction factor that we have get, that is 0.094. So para hindi na tayo mag-compute, we can use that one because we have the same length. So this will be 0.04 C to D. So that will be C to D. We're going to D to D2. Duck. So this is the last part. C. So this should be D to D2. Okay, so sorry, we have to erase mali pala. C to D pa. So we have 0.9. Okay, the value, we'll change that one. So this is the length is 0.9. So we'll change this one. So this will be 0.9. Then the elevation, the equivalent, okay, repairing that one. So ito yung part na yan, D to D2. So we have the equivalent of 0.113. So let's change that one, 0.113. So this is 0.113. Okay. It is 0.113. 133 pala, sorry. So this is 133. So same density. Then we have your friction factor, so we can use that one also. So the friction factor from that part that will be 0.035. Okay. This will be, let's erase this one. So that will be 0.035. Okay. Then computing that one, so we have also the same length, same volume flow rate, same turbulence, so same friction factor, so we can same volume flow rate, same friction factor, so we can assume also this is also the same, or you can compute that one directly, or we can import that one because they have the same volume or discharge noon kanina. So we have your duct here, so we have the value of 0.13. So we have here 0.13 Pascal, the value, since considering they are the same nito length, same volume flow rate, 40 CFM, this is all 40 CFM. Okay. And also we have also